हेलो 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 1 2 3। हो लाइट छोड़ दिया। एक बार चेक कर लो बेशक कोई भी है। आया मैं कर दिया लाइट
कर दिया।
हाँ चेक करो। ठीक है लैपटॉप पे वेट बोर्ड तो लगाएंगे वेट पर बैटरी
सर कल आपने दे सकता है
Good evening. Our honorable speaker has arrived. I request everyone to please take their seats. Good evening, ladies and gentlemen. I request Dr. Mukuldas, Director, Shri Institute for Industrial Research, and Dr. Manmohan Kumar, Deputy Director, Shri Institute for Industrial Research, to kindly escort the dignitaries to the chair of the dais, please. The dignitaries are Shri Somanath S, Shri Alok B. Shri Ramji, Shri Madhav B. Shri Ramji. Respected Shri Somanath S, the Chairman, Indian Space and Research Organization ISRO, and Chief Guest of today's Founder Memorial Lecture, Padma Bhushan Dr. Mrs. Manju Sharma, Chairperson, Governing Board, Shri Ram Institute for Industrial Research, who is virtually present with us today, Shri Alok B. Shri Ramji, Vice Chairman, Governing Board, Shri Ram Institute for Industrial Research, Shri Madhav B. Shri Ramji, Mentor, Shri Ram Institute for Industrial Research, our other esteemed members of the Governing Board, members of Research Advisory Committees, Their Excellencies the Ambassadors and High Commissioners, senior diplomats from the Diplomatic Mission in India, Dr. Mukuldas, Director, Shri Ram Institute for Industrial Research, Dr. Manmohan Kumar, Deputy Director, Shri Ram Institute for Industrial Research, invited dignitaries, ladies and gentlemen. I, Leena Thakur from Shri Ram Institute, feel honoured to welcome you all to this Shri Ram Founder Memorial Lecture 2023. On this memorable occasion, marking the 139th birth anniversary of our illustrious founder, Lala Sir Shri, we pay our respectful homage to him today by organizing the 57th Founder Memorial Lecture in his series. Lala Sir Shri, one of the foremost business visionaries of India, left an indelible imprint of his personality upon the whole canvas of Indian industry. Due to his sustained interest in technical advances and passion for industrial research, he came to be regarded as the father of industrial research in India. He could foresee the need for a strong and self-reliant research and development base in the country and thus formed Shri Institute in 1947, which has been operating as a premier self-supporting institute in the country. Shri Institute was not only started by him, but also flourished greatly under his vision, resolute interest and generous support. Since 1965, every year, scientific and technical lectures have been delivered by eminent personalities from across the globe, thereby making this a major scientific event of the country. Today's Founder Memorial Lecture is being delivered by Honorable Chairman, Indian Space and Research Organization, ISRO, by Shri Somanath Sir, who is an expert in launch vehicle structural systems, structural dynamics, mechanisms, pyro systems, and vehicle launch integration. We will now begin the program by lighting of the ceremonial lamp. May I request our dignitaries at the dais to kindly light the lamp, please. May the light of this lamp enlighten our path of progress. To pay homage and tribute to our founder, may I request Dr. Mukundas to garland the bust of Lala Sir Shri. May I now request Shri Ramji, Vice Chairman, Governing Board, Shri Institute for Industrial Research, to present a bouquet to our guest speaker, Shri Somanath S. Thank you, sir. Following the traditions of our culture, at the beginning of any landmark event, it is customary to invoke Lord Ganesha's blessings. Our scientists will now present a Ganesha Vandana. I now request Dr. Mukuldas, Director, to kindly deliver the welcome address.
Our esteemed guest speaker for the afternoon, Shri Somanath ji, respected chairperson, Dr. Manju Sharma, Padma Bhushan Dr. Manju Sharma. I'm sorry to tell the audience that she won't be able to join the function because of her ill health. Shri Alok Shri Ram ji, the Vice Chairman, Governing Board of Shri Ram Institute, Shri Madhav Shri Ram ji, the mentor of Shri Ram Institute, my colleague Dr. Manmohan, Deputy Director Shri Ram Institute, members of the Governing Board and Research Advisory Council, distinguished guests, dignitaries from various embassies and high commissions, faculty members and scholars from universities, colleges and high commissions and research institutions, members of the electronic and print media, my dear colleagues from SRI and their family members, and most important, my dear students. A very good afternoon to all of you. It is indeed a great privilege for me to welcome each one of you to this August gathering to be the part of 57th Shri Ram Founder Memorial Lecture. Today, we pay homage to our illustrious founder, Sir Shri Ram, on the eve of his 139th birth anniversary. He was a visionary, well beyond his own times, a successful industrialist and an institutional builder who initiated and founded several academic and cultural institutions, including our own Shri Ram Institute for Industrial Research. All at the time when our nation had received its independence and was transiting to a new beginning. Even in those early years, Sir Shri Ram, who was fondly known as Lalaji, foresaw that if India has to progress and become self-reliant, we need to innovate and apply technology to areas that touch our day-to-day living and those which concern the common man. That is the spirit that still embodies Shri Ram Institute. Lala Shri Ram vision was further developed in the later years by the able guidance of Dr. Bansidhar ji, taking Shri Ram Institute to greater heights, which is now being continued to be nurtured under the leadership of Shri Alok Shri Ram ji and Shri Madhav Shri Ram ji. The institute has overcome the adverse effect of COVID times, and the performance is remarkably recovered. We started an online lecture series in the name of Dr. Bansidhar Lecture Series from COVID times. And last year, we had 3 lectures being delivered from the most eminent scientists of the country. That is from Professor Akhilesh Tyagi, the Meghnad Saha Distinguished Professor of Nasi, who spoke on diversifying genome, crop genome. Professor Chandrima Saha, the President of INSA and J.C. Bose Chair, Distinguished Professor of Nasi, who spoke on emerging infectious diseases, the risks and the challenges. And the third was given by Professor V. Ram Gopal Rao, who is the Pillai Chair, Professor of IIT Delhi, on R&D to innovation, bridging the gap in higher education institutions. Apart from this, some of the recognitions were received by SRI scientists during the year, and these are Dr. Mukul Das, director, was placed in the top 2% scientists list of the globe. The updated science-wide authorship database, which was published by Elsevier and Stanford University in August 2022. 3 scientists, Dr. Khushbu Kapoor, Dr. Sapna Gupta, and Udranshu Chatterjee were awarded PhD degrees in various disciplines. Following special events were organized during the year. On the occasion of World Environment Day, Professor Parabjit Khurana, Department of Plant Molecular Biology, University of Delhi, delivered a lecture to the scientists of SRI titled Gene and Genomics for Climate Resilient Crops. The awareness training program was organized on intellectual property and its protection by Mr. Ashish Prabhat, the examiner of patents, Indian Patent Office. Shri Prahlad Singh Patel, Honorable Minister of State for Food Processing Industries, visited the institute and interacted with the scientists of the institute. The director, Dr. Mukul Das, and the vice chairman, Shri Alok Sridhamji, attended the International Climate Summit 2022 on opportunities for green hydrogen in India at Bergen, Norway, held during August 2022. Our Environment Protection Division has been designated by the Ministry of Jal Shakti, Government of India, as a key resource center to impart 3-day residential training to water testing laboratory staff of all the states of the country. A total of 12 training and hand-holding programs were organized under this arrangement. Mr. Lalit Vora, Joint Secretary, MNRE, inaugurated the prototype facility for the demonstration of electricity generation from geothermal hot water. This concept will be utilized by Manuguru, Telangana state to generate electricity of 20 kilowatt from geothermal hot water discharge having a temperature of 65 to 70 degrees. This is one of its own kind in the entire world, I would say, that at such a low temperature of geothermal hot water, the electricity is being generated. The institute has entered into the Memorandum of Understanding with many of the universities and educational institutions, including Bundelkhand University, Karodimal College, R.K. Goyal Institute of Technology, Ghaziabad, Reva University, Bangalore, Bhaskaracharya College, Delhi, Dayal Singh College, Delhi, Venkateshwara College, Delhi, National Research Development Corporation, Delhi, and Delhi Integrated Multimodal Transit System in Delhi. Also, an MOU has been signed by SRI and Green Stack Norway in the presence of Norwegian Foreign Minister and our own Indian Honorable Minister Shri Rajkumar Singh, MNRE, for conducting research in the area of green hydrogen. A new facility has been established at Nainpura district near Bijnor, Uttar Pradesh, for the UV coating of wooden handicrafts under a project which was sponsored by DST. The technology was developed by SRI, and the facility will benefit a large number of rural artisans prevalent in that particular region of the country. During 2022 and 23, scientists of SRI have published several research papers in high impact factor journals, and one patent has been granted, while another 4 have been submitted, besides several oral presentations and the lectures delivered at different conferences and workshops. Shri Ram Institute remains committed to excellence in research and development of new technologies under the able stewardship of our chairperson, Dr. Manju Sharma, and Vice Chairman, Shri Sriramji, and the mentor, Shri Sriramji, and valuable guidance of all the governing board members and Research Advisory Council. During this journey of almost 7 decades, now much has changed in the social and scientific arena of our country, and the world as a whole. But the vision and the spirit that was initiated by Sir Shri still burns bright and meets some of the otherwise not met necessities of the society even now. Today, we are privileged to have with us the distinguished scientist, Shri Somanath Ji, Secretary, Department of Science, Department of Space, who is also the Chairman of the Space Commission and Chairman ISRO. He will be delivering today's lecture entitled Emerging Space Sector in India, Technology, Innovation and Opportunities, dedicated to the memory of our founder. I would also like to introduce the speaker, and he needs no introduction because he is a legend in himself, and the country is proud also as well. One of the most distinguished scientists in space technology, and at present is heading the space research program of our country. He is Secretary, Department of Space, Chairman Space Commission, and Chairman ISRO since January 2022. Shri Somanath Ji has a distinguished career of nearly 36 years and made significant contribution in the area of space technology. Very recently, in April 2023, Shri Somanath Ji and his team at ISRO made our country proud by achieving another milestone in the successful landing experiment of reusable launch vehicle landing system. In his previous assignments as Director Vikram Sarabhai Space Research in 2018, the lead center of ISRO, he was responsible for launch vehicle technology development. Prior to that, he had been the director of Liquid Propulsion System Center, where he led the team to complete the development and qualification of CE-20 cryogenic engine, which was successfully flown in GSLV flight. He is a fellow of Indian National Academy of Engineering, fellow of Aeronautical Society of India, fellow of Aeronautical Academy of Aeronautics. He has published several research papers in reputed journals in the area of structural dynamics and controlled dynamic analysis of separation mechanism, vibration, and acoustic testing, launch vehicle design, and launch services management. We look forward to Shri Somanath lecture entitled Emerging Space Sector in India, Technology, Innovation and Opportunities, which I am sure will be of immense interest for each one of us. Thank you. Jai Hind.
Thank you, sir. As the audience is keen to listen to, I now request Shri Somanath Ji to deliver today's Founder Memorial Lecture, Emerging Space Sector in India, Technology, Innovation and Opportunities.
Good evening, all of you. Distinguished persons on the dais and off the dais. My greetings to you all on the occasion of this 57th Founder Memorial Lecture of Shri Institute of Industrial Research. I'm really honored to come over here and then to make myself familiar with the activities of the Institute and to derive what we can do together. That's the idea of me coming over. I believe that the engagement can really happen between ISRO and the Institute in the long run. And I'm also very privileged to have been given this honor of giving the Founder Memorial Lecture. Of course, the legacy of Shri Ram is well known, and I'm not going to elaborate on it. But I thought this occasion is something that I can showcase myself on the space activities and then to make it aware of the community here, especially the people from the Shri Ram Institute of Industrial Research and all those distinguished invitees who have come up here, on the changes or modifications or improvements, or rather you can say about the reforms that are happening in the space sector in the recent times, connecting it to what we have been doing over the last many years. So that's why I named my topic as the emerging space sector in India, technology, innovation and opportunities. Of course, the technology is something that we never had 60 years back when we looked at space sector. India wanted to launch its rockets and satellites and applications. The technology was simply not there. And over the last many years, we were really very proud of the fact that we could develop it in India, of course with the support of so many people, create the capability to build rockets, satellites, launch applications, and that too from this land itself. Now we have the capability, end-to-end capability today in space sector. And there is a change happening now, primarily because that certain capability has been developed and it has been sponsored by the government in the last so many years. Funding always comes from the government. And we look at how this can get into a business opportunity now and how private entrepreneurs can come into space sector and where the possibilities are. And for that we need to have innovators to come in, not the traditional technologists to work here. And also we must look at what are the business opportunities available to really to do work in this sector and how to create the markets and business potential in space sector is something that we are debating now, trying to work out and to create policies and framework on which all these things can happen. And our goal today is to enhance the economy of space sector substantially in the next, say, 25 years, maybe 50 years, I do not know. It will work out over a period of time, substantially increase from the scale of current economic activity in space sector. So this is the theme of my talk. So let me move on. Change your slides? Yeah, of course. Thank you. So this is something which we are all very proud of to talk about, the historical perspective of space. Started it in a very small manner in India, way back in 60s. With the support of US, France and Russia, we built the initial rockets, the ground equipments, infrastructure, the computers all came from various nations. And Sarabhai was capable enough to do this during the periods of Cold War, even to bring collaboration between US and USSR and Russia to launch the first ever rocket from Indian soil. And later, the capability has been developed to have our own rockets in India. Next slide. Yeah, the Nike Apache was the 63 launcher. Then we developed the Tumba Auditorium rocket launching station, which was dedicated to the world. And many nations came over and built the early rockets and launched from there. You can see Indira Gandhi at the coastal village of Tumba, dedicating the Tumba Auditorium rocket launching station to the nation. Next slide. Today we have a series of rockets. Of course, rockets are very important. Without the rockets, that you can't think of launching the satellites. So, if you really look at the space sector emerging in India, you will understand that initially rockets were not built, though the early rockets were launched in 1963. Sarabhai looked at it as an opportunity to showcase the application of space sector to the decision makers. And we looked initially on the satellite building and application delivery. For that, we even hired satellites from other nations. The US satellite was placed on top of India for communication purpose in 1970s or for almost a year. And almost 1,000 DTH terminals were set up in 70s itself to showcase the television program that was broadcasted by All India Radio at that point in time, to show that space can be useful to the nation. And later this demonstration and application demonstration, government was convinced enough to fund us to build those capabilities. Today we have rockets of various nature, not only the sounding rockets, they still fly every month from Tumba Auditorium Rocket Launching Station to sound the atmosphere. We built the SLV-3. I think all of you know the story of SLV-3. The Kalam would have told it much better way than I could. Then we built the ASLV. Now we have the PSLVs, GSLV and GSLV Mark III. And recently we added one more, the SSLV, and we are planning to add NGLV, the new generation launch vehicle. Of course, this is a very important milestone in creating this capability within India, having people to do this, having technological capability in various disciplines. It's not a small thing, really. Many people who looked at rockets really will wonder how it is created. You need to have end-to-end capability to understand propulsion, material science, manufacturing, integration, testing, avionics, control systems, aerodynamics, varieties of disciplines to be integrated enough to bring the success in a rocket is not an easy task. I think it's not done by many other people. It's a very tough thing to do to create that capability. And then to have this capability, you want propulsion. I think all of you know the chemical rocket propulsion is one of the basis of any rocket building. And we acquired this capability over a period of time with the help of France in the hyperbolic propulsion, with the help of Russia in the cryogenic propulsion. And today we are capable of doing it in India with using our own materials and manufacturing capability and test it and prove and improve it over a period of time. And that's what we are presently capable of. Next. And it's interesting when we look at reforms in space sector, it's interesting to look at what's happening out there. Not to be happy with what we have achieved so far, but what's happening out there is very important. Look at some of those accomplishments. The SpaceX is doing a marvelous job in the US, bringing back the rocket and launching. Initially, this was simply thought of impossible, and now that's happening in a private ecosystem. With the help of course, with the help of NASA, they are able to showcase that rocket launching can be extremely cost-effective. The per kg cost to space can be actually substantially lower than what you ever thought about, making it more democratic in nature. And similarly, the same work is being done by the Blue Origin, by Jeff Bezos itself. And the moving back to moon, again, America announced this program. And many humans flight capsules have come up now recently after so many years of dull period of human space travel other than the ISS. Now going back to moon is again another big agenda. Even in India, we are able to see some small companies coming up with the rocket building ideas. They have launched already sounding rockets, and they have a hope to build huge rockets, reusable rockets in the future. And people talk about colonization of Mars. We will be building huge rockets able to transport hundreds of people at a point in time. For a one-way travel, of course, they won't come back. They will stay there and create colonies of human settlements. And another important thing happening is, because the launching costs have come down, the number of satellites launched per year has substantially increased. Last year itself, almost 2,000 plus satellites are launched. And we have lower constellations for communication purpose. The Starlink is one example, the OneWeb, which we launched 72 of them. And new constellations are announced. And for various purposes, it's for communication, it's for remote sensing, navigation, surveillance, all these activities, even IoT, we have constellations of satellites. So the space is getting crowded because cost of access to space has come down. And not only that, the application segment is also growing. The digital connectivity is improving the ability to have more satellites there and make use of it. So there is a business case. So all these are changing things in the space ecosystem. Next. Now let me go back a little bit on the inspiring part of our work. It's mostly in the scientific domain, possibly you know. The lunar exploration, we did the Chandrayaan-1, Chandrayaan-2, and Chandrayaan-3 is just getting ready, and it's almost ready there in Bangalore, and we are going to launch in the coming month, most probably by June, July. And it has been such an inspiring story for us to build Chandrayaan 1 and Chandrayaan 2. Of course, Chandrayaan 2 couldn't do the final landing maneuver and to land it very close to the surface, but of course 300 meters up there it crashed. But that doesn't matter for us. We are building the next satellite, Chandrayaan 3, with all the capability to handle such eventualities. But the biggest contribution from Chandrayaan that came is the scientific outcome. And stirring up the scientific community in this country to do some useful scientific activities. And also the collaborations that we created between various nations who have the ability to observe and understand Moon, specifically the European and American scientific establishment collaborated with us to host many payloads on board Moon, so we could finally discover water molecules on the Moon. Next slide, please. So this is the publication of finding water on Moon. So none of the earlier missions could identify this. The payload on Chandrayaan, on board Chandrayaan 1, both the US payload as well as Indian payload could identify the presence of water. So and subsequent missions to Moon really corroborated this measurement. Even Chandrayaan 2 did additional measurements to prove that it is true. So this is a very interesting finding which enabled furthering the interest of traveling to Moon. I think the future missions to Moon will be based on such important findings. Next. This is another important outcome of the Chandrayaan missions, finding exact map, very good map of the Moon. And today we have a very good understanding of the topology of the Moon, the places where we can land, the very high resolution images are available, based on which we are able to land on the Moon. And we sourced it earlier for our first mission from various other nations. Today we have enough resources within us to handle missions to Moon. Next slide, please. Look at Chandrayaan 3, and Chandrayaan 3 is going to be doing a different mission than what Chandrayaan 2 did. We are going to probe into the Moon surface to understand what are the scientific interests on the surface of the Moon. That's why we have a lander, we have a rover, and this time I want all of you to pray and blessings with us for a successful landing. Of course, whatever scientific work we do, along with that, this is also necessary. So I seek that part. So we have done all our work very well, I believe. The design of the craft, the algorithm that will take it to the surface of the Moon, the failure modes that are likely to happen and how we can overcome all of these possibilities have been well debated and addressed in terms of the engineering of this, and we hope that it will do its function very well. And we have very interesting scientific objectives in this surface, and all of these are done by Indian scientists. This time we don't have any hosted payload from other nations. All the 10 payloads on board this Chandrayaan 3 are Indian institutions created payloads. And I will tell you, there are beautiful instruments made in this Chandrayaan 3, like a laser Doppler velocimeter. You should look at this instrument. This uses laser as a technology by which that entire movement of the velocity of the craft can be measured with reference to the surface of the Moon. It's a very interesting instrument. After the last failure, we were tasked to design and define this instrument, and our engineers and scientists developed this within our laboratories to build this one of the world-class instruments. Today, when we showed it and discussed with the JPL scientists from NASA, they were really impressed and congratulated us for such an interesting development that has happened in Chandrayaan 3. Next one. I would like to show you just one slide on the Mars orbiter mission. You can look at this image. It's such a beautiful image of the Mars, taken by the camera on top of the Mars orbiter mission, the Mangalyaan mission. So today we have such a beautiful map of the entire Mars surface, and we do a lot of studies on it. It's actually, we have a 3D map of Mars, which is created using the high resolution optical imager on top of the Mars. And this is only one of the results, but there are many scientific outcomes that has come out of the Mars orbiter mission. Even today, scientists world over make use of Mars orbiter mission data for studies. And we launched this satellite for just 6 months of life, and it worked for 8 years. And last 2 months or back, we declared it non-functional because its fuel is over and we can no longer be controlled. So it's still orbiting around Mars, but not able to do the altitude control. So it's a great achievement, and all of you know the Mars orbiter mission is hailed as one of the lowest cost mission ever to go to Mars, and that became successful in the very first attempt. And we don't take all the credit for what we did, because it is the help of various people who actually did this work prior to us. There were many missions to Mars which actually failed, and we learned lessons from them. We sought help from those people, and with all that help, we could do it our own successfully. I think it's a great achievement for the entire scientific community. Next slide, please. Okay, I'll just quickly go through some of the scientific missions which are up there. One is AstroSat. AstroSat is a very interesting instrument that we have placed in orbit to understand the astronomy, astrophysics people, to look at the creation of the universe, look at black holes, look at exploding stars, look at new galaxies, and this is actually a collaboration with various institutions across the country. Built those instruments, came with the scientific ideas, and even now it is working very well. It is one of the interesting observation platforms up in the space for multispectral observation of the universe. And a lot of scientific outcome has come out of it. Next slide. And what we are getting ready for the science mission to study the sun called Auditorium L1. This satellite is almost getting ready for launch, and this launch also is scheduled by July this year, because that is the only slot available to launch, so we have to get ready. And this is another interesting mission to study the sun, look at its corona, look at its radiation, and how it affects the upper atmosphere, upper space weather situation on Earth. And this is a very interesting heliophysics study. We have collaborators from across the globe, but the entire instruments are built in India using the capability of scientific institutions like the IUCAA, the Indian Institute of Astrophysics, and ISRO. Scientists have worked together to create those instruments within India. They are very complex instruments, just delivered and integrated to the satellite very successfully. So here again, like Chandrayaan 3, we need very complex mission maneuver, because it's not going to be around Earth. It is going to travel to a point called Lagrangian point L1, which is a point between Sun and Earth, and it will virtually be stationary there and look at the Sun always without being obstructed by the Sun or Moon. So it's such a specific place. We have to travel almost 1/3 the distance to the Moon. We have to travel and then keep it there for a long time. I made a mistake. It's not 1/3, 3 times the distance to the Moon. Okay. Next. We are also working on another interesting satellite, XPOSat, which is an X-ray polarimeter satellite, which is to understand, look at the polarimetry of the bright X-ray pulsar stars, which possibly those who are interested in astronomy, astrophysics will know it very well. Also look at black hole sources. And this instrument is currently getting developed, and we are getting ready for launch possibly by the 3rd quarter of this year. Next. ExoWorld is another interesting mission we are working on to look at what are the future places human beings can travel and settle. Possibly you know that there are something called exosolar planets, planets in another orbiting around other stars, not the suns. We call our own planet Earth is orbiting around sun, and if it is orbiting around another sun, we call them exosolar planets. And today we have discovered, the world has discovered using various instruments, almost 5,000 exosolar planets. And I can claim you 3 of them were discovered by our own scientists at PRI. So, but we want to use this mission as a technique of finding out what is there in the atmosphere of exosolar planets. This is a spectroscopic experiment in which we will be looking at the composition of the material around the surface of the planets, and to see whether it is a habitable planet or not. And this is one of the interesting missions that we are trying to do. Next. So we have collaborative missions planned between various nations like with France, with Japan, and French. Earlier we had collaboration, and this collaborative scientific missions still continue, and we'll be building instruments jointly with other nations as well to keep a scientific interest in this country. Next. Now, also other scientific missions are very interesting missions, like missions to Venus, mission to study the Earth atmosphere, especially the upper atmosphere. We call it as a twin aeronomy mission. We are also looking at scientific mission data to be made use by various institutions across the country to create the scientific talent pool in understanding Earth's mission, and specifically the astronomy, astrophysics students across the nation. Basically to create the required scientific pool or talent within this country to build instruments of very high quality, understand this, and then publish good peer-reviewed journal publications, etc. So this is another activity. It's not only building the scientific instruments and launching them. To creating the scientific talent pool in this country is also equally important responsibility that we have taken to ourselves. Next. So let me move over from the scientific work of missions to some technology side, because it's definitely a part of my talk. One of the important technology we understand is the scramjet, and this is very important for our missions, specifically in the area of very hypersonic travel, space travel. We are working on various technologies that will build scramjet engines. Possibly, you know, scramjets are the engines where there are no moving parts. Just by the speed of the vehicle, the air gets compressed and you will be able to burn the fuel inside and then create an exhaust velocity which is faster than the incoming air, thus producing the thrust. So this is a very complex engine by itself, and we have flown one with using hydrogen fuel long back, and we are now working on a kerosene-based scramjet engine which will be much more efficient and higher power. So we will be soon hearing about it later when we announce about the scramjet testing. It has various applications, possible space travel, low-cost space travel, so that the fuel oxidizer is from the atmosphere, and it also has strategic interests as well. Next. Another interesting area is the building of rockets which are reusable. I think you know that SpaceX is already launching them. The rocket which will take off vertically, do the mission and come back. The first stage will come back and land using its own landing legs, and we can refurbish and reuse it. The net gain is that you are able to use the rocket maybe 10 or 20 times, which will recover its initial investment of building the rocket, so that the per kg cost of launching a satellite to space can be substantially brought down. So that's the idea. And we are getting ready with the rocket now. One of the rocket is just ready for a different purpose. And we will be adding all the landing, throttling capability, etc. to create the capability in India. But there are many technologies which are required to build it, like the optical navigation systems and algorithms for retropropulsion, aerodynamics, which are very complex when a rocket is coming back. You know very well when a rocket is moving forward how to handle it. But when it is coming back with a rocket engine firing, it's a mastered over a period of time. Possibly, you know, the SpaceX in its initial missions, they were crashing all the rockets one after another. So it takes some time. Recently, they also crashed their bigger rocket. I'm very sure they will come out successfully in the next mission after understanding what really happened. But it's a big challenge, huge investment in building big rockets and understanding it. So unfortunately, we don't have that much of money available. So we build systems at a very low cost. We develop technologies at substantially low cost that are done outside. And that has been the hallmark of Indian Space Research Organization, to develop technologies, show it that it is possible for us to build it at substantially lower cost than what could be done elsewhere. Next. So we are also working on engines which are of the world class. This is the basic core technology required to work on rockets and spacecrafts. We need to develop newer engines. And one of the newer engine is called LOX methane engine. In place of very complex fuels, we can use oxygen from the air, liquefy it, and the fuel is just the kerosene, but not the ordinary kerosene, but it will be a refined kerosene. This has been the semi-cryogenic technology, but later now people understood that it is better to use methane. It is mostly the cooking gas liquefied to a liquid stage. And if you use methane and oxygen, you will be ending up with a very efficient propulsion, which is very reusable, because kerosene has a soot formation and other contamination tendencies, whereas methane is much more cleaner fuel. So there is a development requirement for methane now world over, and many methane engines are already developed. And in India also we are trying to develop a methane engine soon. And we have already done a test on one of the engine sample at a lower thrust, and we are upgrading this engine to a bigger engine soon. Next. We work on various technologies on space and propulsion in advanced propulsion, like the green propulsion, especially in terms of the hydrogen peroxide based, ADN based. I think many of the chemical scientists possibly may understand here. And also hybrid propulsion, where we use oxygen and solid fuel and liquid fuel combined, so you can do throttling of the rocket, as well as using this in some of the early science missions. So this is another area of technology development, because everywhere people want to make everything green. You know? Even rockets also should become green in terms of the environmental impact that we have, and more regulations will come in the days to come. So it's important that we develop capabilities in handling greener propellants greener propulsion, greener technologies more in the future. Next. Another interesting area is the robotics. I think we work on many robotic capabilities. Ground-based robotics, where people are well aware, but once you go to space, robotics is of different nature because our interventions are less. It has to become more intelligent. It has to have more capabilities to handle situations. So we are also developing robotic, mimicking human behavior, and also doing experiments on board like docking, refueling, capturing objects, bringing it back, etc., etc. So assembling complex stages, etc. So that human intervention is not required. Our astronauts are not required for most of the applications. So this is another big domain, and we are working very closely with various stakeholders having robotic experience in India. Next. Quantum. I think all of you know quantum technology is another big domain. There are a lot of areas in quantum. But in ISRO, we concentrate on quantum communication technologies. Of course, quantum computing technologies are there, and various quantum technologies are there. So we have developed quantum communication protocols so that we can implement it for cryptography, secure communication network, etc. In fact, we were about to launch a payload in the last mission. It couldn't be made ready. In another few months, we will be launching the very first ever quantum payload in space to demonstrate quantum entanglement and show that it is possible to generate a quantum key from space for distribution for terrestrial quantum communication networks. So this is the goal that we have. Recently, government has announced a quantum mission, and in which we are one of the important partner in developing this capability in India. Our laboratories have already developed and showcased this in the scaled models of already. Next. We offer our rockets for experiments. I think one of the possibilities for scientists across the nation is to build instruments, build technologies, and we will host it for you in our rockets with very low cost. So this is an offer to you. Possibly you are aware the last Saturday we had a launch of PSLV. There were 7 payloads from Indian startups, industries, and they were hosted on this absolutely no cost, because we have provided them a platform for with power, communication network, and all scientific capabilities so that you can experiment on. Anything that is related to space technology you would like to find out, you don't have to build a satellite today. You can simply talk to us. Then we will provide a space for you in the rocket. It will go to orbit and you can conduct experiment and we will give you the data what is needed. And many startups are taking this as an opportunity. Many institutions are taking this as an opportunity. So this is called the experimental platform called POEM. We call it PSLV Experimental Orbital Module. On top of this, we are planning in the future also many experiments. And primarily our target is students and institutions who have not having so much of their experiments and create some capability. I have mentioned it could be biological studies, or it could be genomic studies, it could be medicine, material development, or experiments related to upper atmosphere or the space. Next. So let me move slightly to thrust over the period in the ISRO has been building the technology, creating capability, developing industries, and building infrastructure in this country for space. But we need to make a change now. The ISRO has to move from the production-oriented organization to an R&D organization. We realize it now that it's high time that we enable industries to do this work and move over to become the technology developer. So this is the change that is going to happen in the coming days in the organization. And we are going to invite public-private partnership to take on this activity of building rockets and launching them. So I am in dialogue with various industries, big and small in this country, to create consortiums so that you can actually gain the knowledge and work with us and build all of this on your own, on a commercial term. You invest, you build, you launch, and make the profit. So this is the offer that we are giving to the entire industry ecosystem. So this will happen over various technology. It will happen for satellites, it will happen for rockets. But you know that satellites are much more easier than rockets. So already there are 5 companies in India ready to build satellites today. This may be news for you, but I want to tell you there are already companies who are having tie-ups in technology tie-ups and capability to build rocket satellites. In 1 year, hundreds of satellites will be built in this nation from private companies. But it will not happen for rockets. Rockets will take a little more long time. There will be a lot of gestation period. Technology upgradation to a level of production could take more time. But we will wait for that. We will try to enable that. But in application side, already there are companies working in this sector having reasonably good market share in terms of the remote sensing data, communication, backup, etc. So application side, there are already companies, but we are looking at how this also can be enabled or enhanced in the period of time. Next. Today we have this many satellites in orbit, which is primarily owned by ISRO. And we have communication, remote sensing, navigation, science mission. And we understand today it is just not enough for the nation. Our nation is so huge. Just 50 satellites is just not enough. We need 500 satellites or even 1,000 satellites to meet the national demand of various sectors. And this cannot be done by government alone. It has to happen only with investment coming from private. It could be building communication satellites, it could be building remote sensing satellites on commercial terms and make use of its services to generate revenue and business. So this is the goal today, and we are trying to work towards this move through an intervention in the policy. I think you have already heard of the Space Policy 2023, which was announced by the government. And primarily this targets is scaling of the economy of space sector from the current level maybe to a one order level higher. And this has to happen with the participation of the private entrepreneurs, private companies, looking at the entire space sector as a business opportunity. And the government and the national space agency like ISRO will focus on creating the technologies which I mentioned earlier, so that after developing this technology, it will be at the disposal of the companies, so that they can convert it into a business opportunity later. So this is a changed model that we want to implement in the future. Next. We have been working on remote sensing. For example, the resolution of the images have improved over a period of time. The spectral capability have improved. Today, we have one of the best class of remote sensing satellite being built in this country. We have all the end-to-end technology, building satellites, building imagers, building cameras, data processing, everything we have today. And also the data downloading capability, dissemination capability. And I am discussing today with private companies. Why don't you come forward, take on this knowledge and build your systems and make use of it as a business potential. And this change we have to bring into this sector as well. Next. We have a navigation satellite system. We created a regional navigation system. You know GPS, all of you know GPS, what it is. It gives you a position and timing service. So we have a national timing service, we have national position service specifically for India, using 7 satellites. Today, some of them are not functional, and we are getting ready to replace them with another 5 more launches. But it is much more accurate compared to the GPS in India. And we want to make it as a standard for each one of you for your navigation requirement. I think all of you are being navigated today by your mobile phones, your cars, your various other tools that you have. Everything contains the navigational information coming from the satellite. And Navic is such a powerful, very accurate, always available satellite compared to GPS. And we said that we are not in competition with GPS. We want to show Navic is much more better for you in terms of accuracy and availability. And this is what we want to provide. And slowly we want to get into the civilian domain substantially with your mobile phones. And new frequencies are coming, which will become mobile friendly in the coming days of the and we would like to see how Navi can slowly expand. Next slide, please. And expand and bring into various other service sectors. Possibly you don't know that today Aadhaar enrollment is Navic enabled. Suppose you go to an Aadhaar enrollment center, it will check the Navic position and see the enrollment center should be located within the boundary of the nation. Otherwise, it will not allow you to enter. So nobody can enroll from another nation outside India. It is geotagged. Similarly, we can use for UAVs, time dissemination for our railway services, our business networks, for example, share, exchange and other places. Timing is very important. Even e-tolling, we are using the Navic today and already demonstrated. At least 1 lakh heavy vehicles are being tracked using Navic system. So it's actually into the civilian sector, but much more can be done in the commercial way in Navic when it really becomes operational. So we are trying to launch another 5 more satellites to make it fully functional for the service of the nation. Next. In India today we have this many industries working for space. 500 old industries, big industries, small industries, but none of them are capable enough to do end-to-end capability. They are all manufacturers of parts, they are suppliers of systems, they are contributing to space by nuts, bolts and brackets. But they are not able to build a satellite, rockets or deliver products. And this is the change we want to build. We are talking to all the industries to say that you invest in space and become a capable space industry, having the ability to understand rockets and build it on your own. And ISRO is going to support you to do this. So this is a change we want to create over a period of time, from supplier to integrator, then to designer of providing end-to-end solutions. So this change is something we call it the space sector reform. Next. And for this we have created 3 entities called ISRO, NSIL and InSpace. And this is something ISRO is well known for you, which will focus on scientific research and exploration. And NSIL will focus on commercial exploitation and business activity. And InSpace will do the promoting, hand-holding, developing new actors in space sector. So this is the 3 divisional labor that we have created within Department of Space. And as a Secretary of the Department of Space, I am responsible to make sure that the roles and responsibility of each of them are well delineated. And we are going to do it in various sectors like startups, industries, as well as with the business activities, as well as public partners, creative partnerships, business opportunities, etc. Next. Possibly you may not know that the PSLVs are produced in India using Indian materials and Indian skills. Almost 80% of the participation is from Indian industries. And it is not done in ISRO. It is possibly you would think that PSLVs are made by ISRO. It is wrong. PSLVs are actually made by Indian industries. And it comes to ISRO for the final assembly and testing. That's all. And much of the materials from this, as much of this material which you see here is actually manufactured in India and sourced from Indian industries. That much capability we have today. Still we are importing some materials in the form of electronics chips and IRL processors. And we are looking at how this area also we can indigenize. It's very important for us to have the strategic independence. But over the years we have expanded. It was only 50% maybe 20 years back. And last 20 years we have converted almost that 30% of the materials sourcing from Indian industries. And it's a big capability that we are developing in Indian industries over the period of time. Next. Next please. So we are looking at how we can also grow into rocket further, developing future rockets, almost 10-ton to GTO launch capability, recoverably, fully recoverable, so that it will be more cost effective. It will do our future human space missions. It will also serve our building of humans, extended human presence in space, etc. So we look at modular, cost-effective, reusable solutions in the future by retiring all our previous rockets, so that one big rocket will serve our purpose in the next 25 years or so. Never I can predict in 25 years what will happen, but at least let us plan today what has to be done today for the next 25 years. Next. We also work on R&D in space sector. Recently we announced 100 technologies to be sourced from private companies, primarily research and development. It's not product that we want to source from industry. We want to source your research outcome into space sector. So we announced 100 technologies that require to be developed in private companies, funded by ISRO, so that it can be sourced from you after development into the space ecosystem. So that's another domain that we are getting in, so that startups and industries can really get funding from government, so that their research can be accelerated within companies. This is something which we have lacked in this country. Just not production. We lack really the research capability in industries in India. And this has to be increased, enhanced substantially by initial hand-holding with them through seed funding, etc. So this is one domain that we are getting in. Various announcements have been done recently to enable this to happen. It has happened in defense as well. Next. Another interesting area we are working is a human space flight. Of course, this has been done within the space ecosystem. After developing the capability for the rockets, space satellites, natural way to get into human space flight capability, we are working very hard on the various technologies, but we are delayed on these missions to sending the human beings to space. We are at least hoping this year we will be able to make the unmanned mission, but flight of a human being to space is really a tough thing. I realize it very well today, because we need to guarantee that he will come back, not only launch him. So to bring him back, we need to have the required expertise in terms of handling the contingencies, safety of the whole system, crew escape system must be very reliable, the environmental life support system must be proven very fully. Then only we can send an Indian on board the rocket. But setting them up there is very, very easy. Anybody who put in a rocket will definitely go to orbit. But this is a very different ball game. So we have a series of test plans and qualification plans that will enable this confidence building over a period of time. And I believe by 2024-25 timeframe we should be able to do that. But this year itself, or maybe early next year, we will have a launch of an unmanned mission, and we will bring back safely the crew module from space in that mission. And we are working on various technologies leading to the human spaceflight. Possibly you know that sourcing of this technology is a very tough one. Nobody in the world just like that give you this knowledge. Though we have tried with all the nations who have the capability, only very little bit of information and help that will come. It has to be done by ourselves. There are very complex areas like the suits that we wear, the food we eat, the oxygen and water recirculation plants, temperature control, safety of the people, the processes that are involved, the global coordination that is required for human spaceflight mission. These are very complex problems. So we seek help of various actors like our Air Force, Navy, and our laboratories in this nation. All of them collaborate to create this capability in this country, and we are leading that activity to make this dream possible. Next. We also propose to industries, why don't you take up tourism as an opportunity in India? There are people willing to travel just for the fun of it, to go to edge of the outer space and come back. So if you ask any of you to willing to go on a tour to space, I am sure many of you will raise your hands, but you will have to bill a check of reasonably good number for doing it. But then it gives you an opportunity for understanding space and getting the thrill of space. When we develop the human space flight capability, this is not far away. And the rockets are available and the escape systems are available without much risk. You should be able to go to hundreds of kilometers and come back and enjoy seeing the Earth from the space. And many of the space tourism companies outside India are coming to India and they are trying to establish capability within India, looking at the opportunity that is available in India. So we propose such a thing to industries and we hope that there will be good response. Next. We are looking at possibilities of refueling in space. Like the refueling happens in aircrafts, and we are developing technologies very important in the future to minimize debris, to discard non-functional satellites, etc. So this capability is something we are going to demonstrate in the future. And these are opportunities for new technologies, development and startups. Next. Similarly, issues related to debris. I think all of you know that number of satellites in space is very large today. Trackable objects are almost 25,000. And non-trackable is almost 5 lakh pieces of objects are there in space. All of these are dangerous objects, and we need to bring back, collect or remove them from the space for the purpose of space debris removal, and recycling processes are very important. And this area, there are a lot of startups working in India. Some of them have produced good results also, like observation platforms, cataloging them, finding methods by to eliminate them, capture them, bring back. All these are business opportunities that are available to new space actors. Next. 3D printing. In space, your organs can be printed much better in space than being printed in ground, because there is a gravity, and gravity brings every object down because of its own mass. And if you do the printing in space, you can actually print heart and lungs and liver, etc. much better in space. And there are technologies getting developed to create this capability for printing in space and then bring back safely so that it can be servicing to the people. And medical benefits of the space colonization is something very, very phenomenal, and upon it, various businesses are already been built in places. And I am very sure in the future, human space travel will be focused on one of the important goal of medical benefits, drug discovery, and are related to printing and growth of various bioorganisms, etc. This will be very important domain in which space is going to be very supportive. Next. We create large ecosystem by which we can interconnect. And this is the power of space, like IoT, drones, networks, centric elements, all getting connected to space. And we find in the future, there will be larger connectivity of objects that you see in day in and day out to the space ecosystem. Today, mobile phones cannot directly talk to satellites, except for some of the phones. But in another 2-3 years, you will see that your communication will be directly through satellites. And most of the mobile phones will be satellite friendly. It will not detect whether it is from tower or from the satellites. It will be seamless, connectivity will happen in the future. And this is going to be true for your machines, your equipments, and your computers and whatnot. I think the IoT is ever connecting, and your entire planning or manufacturing networks, your delivery networks, your sourcing networks, all will be connected through satellites. And this is the power that we have having a space backbone. And here I am very sure more applications will emerge in space sector on account of this. Next. We also work on domains like the one which was announced here, the reusable rocket, which is very important for us, because in the future we see there is a potential for this to go to space, remain there for some time, do certain activity, come back and recover their payload from there, which is going to be very important from civilian as well as strategic use. And we are trying to develop this capability within India, and we are very happy that our first attempt to land autonomously in a landing strip was successful. And we will be repeating this few more times to demonstrate its design ruggedness. But we are developing already a big one, not this one, the one which we launched, the one which is going to go to orbit, which you can take a satellite and then come back. And that currently manufacturing of that and testing of various systems are going on. We hope in another 2 years of time we'll be able to launch it to space and bring back as well. Next. We work on materials technology. I think this is the key to the future. And various technology, materials technology, we have developed it is metallic, non-metallic, manufacturing, superconductors, hard material, high temperature materials, nanomaterials, power generation, power storage. And there are so much of scientific capability existing in our organization which is capable of building it. And we collaborate with so many laboratories and institutions in this country to work on material science as a very core strength of our space program. Possibly you will think that everything is not propulsion. We need to work on fundamentals. Next. And we work on various innovations in this sector. I don't want to explain all of them. For example, electric propulsion is another very important area. Through this process, you will be able to bring down the satellite sizes and also to have it more efficient. Deployable structures, very important element, because we can't launch huge structures. The present satellites, some of them are very huge satellites, like 60 meter by 50 meter size satellites. But unless you are able to fold it into a compact size, you cannot launch them. So you need to create mechanism by which you can create flexible, expandable, or collapsible structures. This is very key development area. You can look at advanced materials of various nature, which I mentioned. So electronics of various nature. Miniaturization is very important. Using commercial grade electronics in space with a reasonable amount of reliability is very important. So there are a lot of technological domains that are open to space sector. Next. We look at the private entrepreneurs coming in space sector in rockets. You have heard about some of these people like the Skyroot and Apnicul. There are also in satellite building, there are companies like Dhruva, Pixel. They are already established as small satellite builder. There are people in application side in debris, geospatial solutions, communication services, orbital transfer services. These are people already working in space sector in India, and many of them are incubated in some of the IITs and other institutions, showing great promise. I have not listed all the companies. There are almost 150 of them. But some of them very prominent ones I have listed here, which shows that there is a great potential for young people to start space-based enterprises and look at the possible expansion in the future. Next. So we also work with the various new actors in this. For example, Apnicul, we worked on the 3D printed engine. This was recently tested in ISRO. The Bellatrix Aerospace, their electric propulsion thruster was tested in our facility. Astrogate Labs look at optical communication for quantum communication related AI and ML solutions with these companies. We also looked at debris management solutions with a company called Digantara. So you can see the change happening now. The private companies are developing capability to a level that they are able to talk to ISRO and then co-develop systems for the market. So it's already happening in the last 2 years of time when we announced this change in our policy. Next. So there are many startups. I am not going to explain all of them. So SatSure is a very successful startup in Bangalore. Looked at remote sensing data as a solution for banking sector. And lending is today happening through the intelligence provided by this company for agricultural lending is used, and they are able to expand their business substantially bigger. Vasundhara is also a remote sensing satellite aerial platform which solves many of the solutions. So many areas like agriculture, environment, governance, energy, mining, all these areas remote sensing data has a huge commercial potential, not a national service potential. So companies who are willing to invest in this, look at solutions to specifically tune to the sector, can really make a big inroad in this sector. Next. So we look at the overall program of space like this. So we look at the business of space sector to grow from 2% to a substantially bigger area. 2% is the scale of the economy of space sector vis-a-vis the global space economy. So Indian share is just hardly 2%. We look at how it can be expanded to say 10% over a period of time. We are also looking at how from the subsystem provider, how industries can scale up to a level of overall system provider. We also say that the technology is developed in ISRO, how it can move to industry so that they can actually scale up and build systems on their own. So if these three things happen, then we will achieve our goal of scaling up our economy substantially bigger. So we created a policy framework which is announced as the Space Policy 2023, which enables these changes to happen. So any technology which is developed in ISRO using public funded, that means government funded program, is accessible to a private industry today at substantially lower cost. You can use the facilities in ISRO for development of a system in private. This is also allowed. So it's a very big change. The entire data that we have collected over the last so many years is accessible to the private people for creating a business opportunity in the future. So all these are big changes, and we must thank the government for that vision and the change that is necessary at this right point in time. And it becomes the responsibility of the Department of Space to enable this to happen through appropriate actions which are coming out of the policy now. Next. So we look at how the numbers we look at later by 2047. If you do all of this right and the change in the industrial ecosystem happens, I think we will lead to something like this in terms of the economy, scale of the economy, in terms of the launches, in terms of creating industries in India who are capable of handling space system forward in a big manner. And ISRO and Department of Space will continue to work as a technology enabler, developer of technology, looking at national prerogatives, serving whatever is required for specifically for the nation, hand-holding the private ecosystem in a manner that they will be able to handle the risks associated with working in space system. Next. So this is a roadmap which I have prepared for the government purpose, which I am displaying to you. So to see that how we will progress in each of the sector over a period of time in strategic domain, in innovation exploration, human space flight, launch cost reduction, as well as enhancing the business activity such a way that over a period of time we'll be able to build capability through appropriate government investment as well as a private investment to create whatever is required in the space sector to grow substantially, to become a very leading spacefaring nation in the future. Next. I believe this is my summary slide, or there are more slides I believe. So it's same thing I stated in a different manner, so I will skip it. Next. Next please. Okay, thank you. So with that, let me conclude. Thank you for the opportunity to give a glimpse of what is happening in space sector now. And all of us are very thrilled and inspired to look at it in the future. And it's no longer going to be an ISRO activity alone, it's going to be a nation's activity. And for that we need the co-travelers or co-workers or co-developers of system. I believe many of you who are here who have an aspiration to work in space are most welcome to look at the challenges that are available to you. Thank you so much.
Thank you so much, sir, for giving us an insight of the advancements in the field of space sector and an overview about India as a bigger player in the global space economy through your thought-provoking lecture. May I now request respected Shri Alok B. Sriramji, Vice Chairman, Governing Board, Shriram Institute for Industrial Research, to please present the memento to our guest speaker.
Employees are a valuable asset of any tradition of Shri Ram Institute to honor the employees who have rendered several years of yeoman service to the Institute, we will now be presenting long service awards. May I now request Shri Alok P. Shri Ramji to present the long service awards to the employees. In the 30 years category, we have Mr. Rakesh Yadav, a manager working in purchase department. Mr. Rajiv Kukreja, a scientist and expert in air quality assessment. Mr. Arun Kumar, an expert in metal and mineral quality. Dr. Bhupesh Sharma, scientist heading Technology Business Incubator. Mr. Ajay Kumar Raghav, a scientist and expert in civil and road works. Mr. C. N. Rajanna, an executive working in administration at Bengaluru branch. Mr. K. Kunaka Reddy, an assistant working in techno-commercial section at Bengaluru branch. In 25 years category, we have Mr. Amit Kumar, an executive working in accounts section. Ms. Kavita Jain, scientist working in food and farm laboratory. Mr. Manish Kumar, plant operator working in Shri Ram Applied Radiation Center. Mr. R.S. Mandal, an engineer working in civil and road works. Ms. Sangeeta Gupta, an executive working in techno-commercial section. Mr. Rajesh Kumar, a scientist working on petrochemicals in Bengaluru branch. Dr. Ramasubramanian S, scientist working in the area of fuels in Bangalore branch. Thank you, sir. May I now request Shri Madhav P. Shri Ramji to present the long service awards to the employees. In the 15 years category, we have Ms. Surmi Gupta, scientist working in drugs and pharmaceuticals. Dr. Nikhilesh Rajput, scientist working in instrumentation. Mr. Devendra Patel, scientist working in pesticides laboratory. Mr. Ram Bhajan, scientist working in the area of pesticides. Mr. Vikas Kumar, a marketing executive for BioGood. Dr. Praveen Kumar, scientist working in metal and mineral division. Mr. Sanjay Kumar Singh, scientist working in rubber and polymers. Ms. C. Sunita, scientist working in Food and Farm Laboratory at Bengaluru branch. Mr. P. A. Chandrasekhar, working in techno marketing for non-wire group in Bengaluru branch. Thank you very much, sir. In order to express our sincere gratitude to the speaker and all our guests, I now request Dr. Manmohan Kumar to propose a vote of thanks.
Today on this memorable occasion of 57th Founder Memorial Lecture. Today's brilliant and inspiring presentation by Shri Somanath ji has really enlightened all of us about the technologies, innovations, opportunities in the space sector. Actually, he has taken us the journey which was started in 1960s with humble start. And today, which you have seen, he is proposing the up to 2047. What are the things we will be doing? And you all will be agreeing that it was really very, very inspiring, especially to the young people, how our country has changed. From the tenure of embargoes which we faced in the earlier years of our country faced, now we are ready to even fly and export these technologies to other countries. And the type of progress which we have seen in this, you all will agree that our country is unstoppable mode now. We will definitely achieve goals which we can think or dream, anybody can think or dream. So this is very encouraging for the young people who are young students who are sitting here. Sir, your years of research, your in-depth understanding of the subject and your ability to present the subject in such an interesting way produced one of the most memorable evenings today. On behalf of Shri Ram Institute management and staff, I would like to express heartfelt gratitude to Shri Somanath ji. May I express my profound gratitude to our chairperson, though she is not present here today, Mrs. Manju Sharma ji, for her support and guidance in organizing this event and inviting such an eminent expert for today's function. Her valuable inputs in all our activities ensure that we always do the right things in a right way. I feel honored and privileged to thank our Vice Chairman, Shri Alok Shri Ramji, and mentor Shri Madhav Shri Ramji. They have always been a source of constant inspiration and driving force to all our scientists and staff in their various endeavors. I would also like to thank our director Dr. Mukul Das ji and the SRI family for meticulous planning for organizing this event. My sincere thanks are due to Dr. Mrs. Anju Srivastav, Principal Hindu College, for permitting us to organize today's event in this beautiful auditorium and providing all the necessary logistic support. From the inner recesses of my heart, I wish to thank all the guests present in the audience who, despite their busy schedule, have taken time out to grace this occasion with their presence. I would like to express my profound gratitude to the senior government officials, distinguished diplomats, scientists, academicians, young students especially, who are our torchbearer, future entrepreneur and unicorns. All our sponsors and members of the media who have honored our invitation and contributed immensely to the success of this today's function. Last but not the least, I would like to express my hearty thanks to Dr. Veenu Dalwar and Mrs. Leena Thapar for nicely comparing today's event, to all my colleagues and staff of SRI and staff of Hindu College for their constant support, untiring efforts and teamwork for making this program a success. Thank you and best wishes to all.
With this, we have come to the end of today's program. We hope that you have enjoyed the program and will again oblige us with your gracious presence in the Founder Memorial Lecture 2024, which would be the 58th in the series. Wish you a good evening. May I request you all to join for refreshments. Our volunteers will escort you for the same. Thank you.
लाइट बंद करना है ना? एक मिनट, 2 सेकेंड, रुक जा, एक मिनट, रुक जा। हो गया ना? बंद कर दिया।